Here are the answers to page 391, number 7 and 10. Go ahead and pause the video right now and just compare your answers and then proceed to see how these answers are obtained. All right, so 7A gave us the picture. I know I told you in the lesson that the pictures were given for both, the 7B, you did have to sketch one. It wasn't any harder than this. It kind of gives you the nice layout here, but it changes from triangles to squares. So let's first take a look at A. Here it says the base of a solid is the region between the curve y equals 2 radical sine x and the interval 0 to pi on the x-axis. The cross sections perpendicular to the x-axis are first equilateral triangles with bases running from the x-axis to the curve as shown in the figure. So the easiest way is just to take one of these cross sections and label the important information. So the entire base is what I have here in green, which would be this. And then this would be the 2 radical sine x. So if I just wanted to do half of this to help me, again, I'm creating a 30, 60, 90 triangle to help me find the height of each triangle. So half of that length would just be the radical sine x. Then I would take that short leg and multiply by radical 3. Now, for this problem in particular, I just want to leave them separate. So now the area of each slice is a triangle. So my entire base, again, will go back to being the 2 radical sine x. So the area of each slice is going to be 1/2 my base, which is 2 radical sine x, my height, which is radical 3 times radical sine x. Now, the reason I left it this way is because radical sine x times radical sine x will just turn into sine x. Half of 2 is 1, so I get radical 3 times sine x, or sine x radical 3. So now when I go ahead to set the volume up, I'm just going to put that radical 3 out in front, but it's still the integral from 0 to pi with respect to x here, just sine x dx. Very simple antiderivative to take here. So watch your signs though. So the antiderivative would be a negative cosine x times radical 3 evaluated at pi first and then at 0. And again, going through this very carefully, we get a negative radical 3 cosine pi minus the quantity of negative radical 3 cosine 0. So cosine pi is negative 1, turning that negative radical 3 to a positive. Over here, cosine of 0 is 1, so I get minus a negative radical 3, which will turn into plus radical 3, giving me 2 radical 3 cubic units. All right, now for B, I just recreated this axis that's kind of laid down on the floor, but instead of these equilateral triangles, I'm drawing squares now. So this is what the figure, as best as I can sketch this, is going to look like here. So now I'm going to just take a square, and the base is the 2 radical sine x, and the area of a square is side times side, so I just square that one side, and then that turns into 4 sine x. So again, I'm just going to put the 4 on the outside, the integral 0 to pi of sine x. Then I get the antiderivative of negative 4 cosine x, again from 0 to pi. So I get a negative 4 cosine pi minus a negative 4 cosine 0. This will give me a positive 4 here, as well as the second term, and I get 8 cubic units. All right, and then for number 10, again, it was nice that we had the figure sketched for us. Here it says the base of the solid is the disk. We're looking at just a circle here, but is less than or equal to 1. The cross sections by planes perpendicular to the y-axis between y equals negative 1 and y equals 1. So we're doing this with respect to y. So this means I want to take this equation and solve for x in terms of y. So I get x is equal to the square root of 1 minus y squared. So now I'm going to take a right triangle. Notice it says isosceles right triangles, so my base and my height are the same, which is going to be, now this radical 1 minus y squared is only half, and even though it may not look it, they are evenly spaced on both sides, so I need to double it for the entire base, so it's 2 times radical 1 minus y squared. And then area of each slice is going to be 1/2 times 2 times radical 1 minus y squared times it again. So I'm still going to have a 2, and then multiplying the 2 radicals together just gives me the quantity 1 minus y squared. The volume, again, with respect to y, I can go from 0 to 1, or you can go from negative 1 to 1. If you go from negative 1 to 1, you don't need that outside 2. I did that here, so this other 2 ends up right here. So just going from 0 to 1, which might make evaluating a little bit easier, I doubled it. All right, so then I could pull the other 2 out in front. We get a 4 times the integral 0 to 1, 1 minus y squared. Take the antiderivative, carefully substitute in, and this is how we're getting 8/3 cubic units. All right, guys, so as you were going over this, as I always say, please let me know if you have any questions.